So if we look at our plan for the AES, I mentioned it in the planning video, but we're actually going to go to the processes to begin with. Because the audio effects are the most important part of the whole thing, we need to make sure that we're actually we have them taken care of before we worry about the superficial things of do we have the correct audio input settings, and how do we route and manage the OSC effects properly. So the first one we're going to start with is delay. And although I'm not a massive audio man, I do know a lot about making delay. Thankfully, it's one of the things that I studied back in the past. So we are going to focus on delay, and the stacking feature is actually fairly straightforward to add as well. So the first thing I need to do is make my testing environment. So I'm going to find an audio snippet that is about 1.5 seconds long, and I know you can use whatever you want. Something like this. Something that's not really repeating is really good to start with. So I'm going to bring in vibes, and then it's going to go to a gain. I like mine's this way, and then just an easy DAC so we can output it. And I'm going to make this stereo, set that up, make this loop. And there we have it outputting the dongs of vibes. Now, what are we making? We are making a delay. And we're not going to use the conventional delay here, purely just because it doesn't give us enough control and it doesn't work the way that you would think. We want to base ours on the live input. So first I'm going to patch our delay, and I'm just going to put in today's date, 0904. I do that so I can just keep track of everything. And then I'm going to plug, oh no I'm not, because I'm not given it an option. In the spirit of modularity, one of the big things that we're trying to implement here, I'm going to set this up like this, so that my delay patcher already has an in and an out, and that plugs into my system. So now when I push play, I'll get a visualization for you. So both our sounds, well, both our spectros show the exact same thing because we've not done anything inside delay yet, but we have a pass through, so we can get started. Now the delay we are going to make is built using the tap in and tap out feature or object. And these work by creating an independent, constantly rolling buffer that we then go into and access data from. Unlike the delay object that simply delays it by a number of samples, this allows us to go in and sample multiple lines from a single buffer. And unlike the actual buffer storer, this is rolling, so it's a really unique type of object. So I'm going to make a tap-in, which is a delay buffer of, I'm going to put 10,000, which is 10 seconds, 10,000 milliseconds. I'm going to plug my audio into that. And then I'm also going to make a tap out. Now the first thing you'll see when we connect a tap in to a tap out is that we get a grey data bar rather than a green and yellow signal bar. And that's because the tap in doesn't actually send anything to the tap out. They're just connected so we can say tap out, go into the tap in buffer by X amount. In this case, we're going to say 1,000. So this is creating a loop that says go into the tap-in buffer for the tap-in buffer of 10 seconds, go back 1 second and play that audio. And because it's on a rolling buffer, it means that the delay is constantly going to be updating with the audio, more how you would expect a conventional delay to work. So now if I push play and turn off this, we can see our first bing. This is the only one we're hearing because that's the one that is being routed. But if I connect that to that, these are now a second apart. If I want to change that, I change this number. Let's make it 2 seconds apart. Or if I want to make it really short, so although this is a 10-second buffer, it will only record the audio that's available to it. If there's no audio, then it'll just be a shorter buffer. This is the beautiful feature of tap in, tap out. Let's not delete a patch. Let's clean up it outside a bit. Stop our bongs and come back into delay. So one of the main things we want to be able to do is not only delay it, your tap in buffer will also trigger anytime you reference MSP data for some reason, unless you clear it. It's just so if you're doing audio changes inside this patch that has the buffer, it will keep outputting stuff for some strange reason that Macs haven't worked out yet. So one of the main things we want to be able to do is stack our delays, and tap in, tap out has this amazing feature. Because we're doing a 10-second buffer, we can make as many tap ins, tap out lines as we want from that, simply by adding extra arguments. So I can make a 1 second, 1.5 second, and a 2 second delay simply by adding the numbers. If we push play, so I think the problem we're running into is I think Vibes is actually a 1 second clip. Does this have a length? Display. I don't know using the playlist app, but there is a way to get a length of the current playing one. And I think Vibes is a second long. That's why we're not hearing all of the dings. But now that we have this, we could easily alter the length of the delays purely by plugging numbers into these three here. But because we're setting this up for touch integration, I'm going to do a multi-slider. My multi-slider, I'm going to make 3 sliders for 3 values, not 32. And I'm going to range it between 0 and 4,000. That's normally a good value to start with. So now if I make this a bit more square, I control click it. I have 3 values that I can control. And one of the nicest things about tap out, which delay just isn't able to do, is we can now dynamically resize our delay buffers as they play. So if I push play, I can turn the delay off altogether, but it will currently layer up 4 sounds, which isn't what we want. Oh, do you know why we couldn't hear any dings earlier? It's because I didn't actually connect the audio out. So now we currently have 4 sounds layered on top of each other, which is bad, and we'll address that in a second. But if I set this up, you can see that we have the delay that I'm able to alter in real time simply by adjusting the length of my output buffer. And because tap-in is stored separately, this won't have any weird audio effects or glitches that you would expect from a non-conventional delay style using the delay object. What I'm also going to include, I'm going to do a multiplication tilde. I'm actually going to do 3. And we are going to use these to individually control the volume of our delays. Because it's very important that if we have all our delays down here, we don't appreciate that they are not actually off. They are all just playing with a 0 delay, which means that our volume is at about 400%, which is very bad. I'm going to duplicate my multi-slider, and I'm going to change my range from 0 to 4,000 to 0 to 1. And I'm going to be really certain that I go and make our unpack float values by adding the period, as otherwise Macs would just treat that as a 1 or a 0. Now, if I push play, add my delays, you'll hear that we can't hear it yet because my volumes are 0. But just like tap out, I can in real time adjust the volume of my delays. We need a few more things here. I'm actually going to make another inlet. I'm going to plug a massive toggle into. And I'm going to use this. I'm going to add one out here as well. Oh, I think my mouse has just run out of batteries. My mouse did indeed just run out of batteries, apologies. As I was saying, I'm going to add this big toggle here. And this is going to be my controller for the entire delay. Because not only do we want to be able to access and individually remove the delays, but we also want a global controller just to be able to bypass it altogether. So another multiplication tilde. All 3 of our samples can go into the left-hand channel of this. Because they don't influence each other when they go in there, it means that it's not altering the level of our overall audio. So now, if I push play, doesn't matter what my volumes are set to, or my delays, because the entire thing's being bypassed. Turn it on, and instantly we start getting our delay coming through. On, off. So we just have a global setting that allows us to control it. And I have the toggle in here and out there for a visualization. Because the entire thing's meant to be modular, we want to be able to plug in anything, anywhere. We add a second 2 outlets, or inlets, excuse me, and plug these into our multi-sliders. Going to copy them. Paste them out here. Make sure you plug them in the right way, because remember the values are different. But there we go, we can now control our entire delay patch. It will reflect in real time inside. And we have the building, or the start of our modular system. Let's mix it up a bit. Let's try a different sound. Let's bring in this. We only need to plug it in one place because of our modular system. I can instantly turn them all off, turn them all on, and adjust them in real time. And that is the start of our delay.